Hello everybody, welcome to the live session by Infinity Learn by Sri Chaitanya. I am Misbah, your maths educator, and in this class we are going to learn how to form polynomials when sum of zeros and product of zeros is given to you. Basically, we'll specifically concentrate on quadratic polynomials, but obviously it can be done with cubic polynomials and a polynomial of any degree. So are you guys ready? Hello Shubham, welcome to this session. Am I audible and visible to you? Just confirm that in the chat, guys. Hello Hidden Soul, welcome to this session. Hello Harsha, am I audible and visible properly? So in this session, we are going to talk about a very important topic according to your school examinations as well as other competitive examinations, that is formation of polynomials. Hello Gaming, welcome to this session. Hi Sajjad. Hello Melly, welcome to this session. Welcome to this session everybody. Okay, so let's give me some seconds. Okay, there is some issue, just give me some seconds. Okay, so let's start with it, guys. So in the previous session, we have already studied the relationship between zeros and coefficients of polynomials and have practiced many questions on the basis of those concepts. Hello Habib, welcome to this session. And in this session, we are going to talk about formation of polynomials. So before actually talking about formation of polynomials, I'll give you one simple question on how to find the relationship between zeros and coefficients of a polynomial. Hello Harsha, welcome to this session. I am good Gaming, I hope तुम भी ठीक हो. चलो एक छोटा सा question I'm giving to you. Suppose you've got a polynomial like this. Suppose 2x cube plus 2x square plus 3x plus 5. And suppose its zeros are alpha and beta. We have done these things in the previous session. It's a kind of revision, you can say. Can you find the value of a cube plus b cube, guys? Can you find this? If suppose an alpha and beta, these zeros. Okay Aisha, yeah, we are just starting. I'm good Gaming, I hope तुम भी ठीक हो. I hope हर वो इंसान ठीक है जो सेशन में है और जो नहीं है वो भी ठीक है hopefully. चलो, okay Habib. So try doing this question and let me know the answer over here. So can you find the value of alpha cube plus beta cube over here? If suppose you are being given with this quadratic polynomial. So obviously anything can be asked, and we did many questions in the previous session on the basis of this relationship between zeros and coefficients of polynomials, right? Alpha is equal to minus 3 by 2. Basically over here, you'll not be able to find the real zeros of this quadratic polynomial, Sajjad. They will for sure try to give you a polynomial of which real zeros are not possible. I mean, you'll not be able to find alpha and beta separately. So therefore, you have to use the Vieta's formula which I had explained in the previous session. No Gaming, ऐसा नहीं है. Okay, beta is equal to 5 by 2. You will not be able to find that because if you will study about something called discriminant, so discriminant of this polynomial is negative, right? You see 3 square minus 40, that is negative. So you cannot find the real zeros of this polynomial, Sajjad. You must have done some mistake. So basically you can only find these zeros in terms of alpha and beta. I mean alpha plus beta and alpha beta. So what is alpha plus beta? We have done in the previous session. Alpha plus beta is minus b by a, right? We have studied Vieta's formula which tells you how to find the relationship between zeros and coefficients of a polynomial of any degree. But obviously we are just restricting it up till quadratic polynomial. We are doing according to the syllabus of CBSE, right? So minus b by a will be minus 3 by 2 over here, right? That is minus 3 by 2. And alpha beta over here is equal to c by a. That is the constant term and the coefficient of x square. So that is 5 by 2 over here. I hope it is clear. So alpha plus beta, the whole alpha cube plus beta cube, we have studied in grade 9 that it can be written like this: alpha plus beta, the whole cube minus 3 alpha beta into alpha plus beta. This is just an identity which you must remember over here, right? I hope this is clear. Thanks Gaming. Okay, so over here alpha plus beta is nothing but minus 3 by 2. So just put the value over here. Minus 3 by 2, the whole cube minus 3. Alpha beta we have got to be equal to 5 by 2. And alpha plus beta we have got to be equal to minus 3 by 2. So basically this is the answer. You can calculate to get the answer. Any doubt in this question to any student in this session, tell me. It means you will not be able to find alpha and beta separately. They will for sure give you a polynomial of which you'll not be able to find real zeros because they want you to use the concept of Vieta's formula, which is the relationship between zeros and coefficients of a polynomial. I hope it is clear. So you have to manipulate the given expression. Over here it is alpha cube plus beta cube in the form of alpha plus beta and alpha beta. It depends on the expression, obviously, needless to say. Is it clear to everybody in this session, guys? Any doubt in this thing? Okay, now we are going to learn formation of polynomials. Formation of polynomials basically. So you see over here, suppose you have got a polynomial whose zeros are alpha and beta. So the polynomial can be written like this, guys, x minus alpha, x minus beta. We have studied in the previous session, and in the, like, since 2 sessions we are doing that. My name is Misbah Gaming. Vegetable, not able to understand that, Habib. This equation works if any root is there. Yeah, this thing will work if the root is real or imaginary, no problem in that, Habib. Okay, this alpha plus beta is minus b by and alpha beta is equal to c by a will work for any whether it is real or it is not real. It will work for that. Okay, but obviously if this is not if you are not able to find its real zeros, then you will not be able to easily find alpha cube plus beta cube. Yes or no, Habib? Then obviously you have to use this relation only. You got that logic or not, Habib? So therefore you need to know this relation. This is for every type of zeros, whether real or imaginary, no problem in that. I hope it is clear, but obviously I did not talk about imaginary roots because you are there up till grade 10 only, so you'll get confused maybe. If you have studied, that is good, but if you haven't studied, you'll get confused, right? Okay, I hope it is clear. Now if these zeros are alpha and beta, the quadratic polynomial can be written like this. Now my question is this the only quadratic polynomial whose zeros are alpha and beta? Tell me. Is this the only quadratic polynomial whose zeros are alpha and beta? Can you tell that, guys? No, this is not the only quadratic polynomial whose zeros are alpha and beta. No, Habib. A simple reason you can see, for example, I am writing x minus 1, x minus 2. So is this the only quadratic polynomial whose zeros are 1 and 2? No. The answer is no, because suppose, Habib, I multiply by 5 over here. Still you will see the zeros are 1 and 2 or not. You got that logic? Suppose I multiplied by 8. Still the zeros are 1 and 2 or not? Tell me. If I multiply by an irrational number as well, suppose root 2. Still the zeros are 1 and 2. So therefore there are infinite such polynomials whose zeros are alpha and beta. You got that logic? So basically this polynomial can be written like this k, where k is any non-zero real number. K is any non-zero real number. It can be rational, it can be irrational. So there are infinite such polynomials whose zeros are alpha and beta. I hope it is clear. Is it clear? Now if you multiply and open up this bracket over here, if you simplify it, you will basically get this thing. You can just do it immediately. So you'll get x square minus alpha plus beta into x plus alpha beta, right? You'll get something like this, x square minus alpha plus beta into x plus alpha beta, and this is written like this, k into x square minus alpha plus beta is what? Sum of zeros, right? This is sum of zeros. So x square minus sx plus alpha beta is product of zeros. So we can write like this or not? Tell me. Okay, yeah, that's what I'm saying, Joynil. Yeah, you can, negative version you're talking about, it means you're talking about k is equal to minus 1, Joynil. Yes or no? If you're talking about the negative version, it means k is equal to minus 1 you're taking. So k can be any non-zero real number basically. It's not just about negative or whatever it is. I hope you got that logic, right? So basically the polynomial can be written like this, x square minus sum of these zeros plus product of these zeros into any non-zero real number k. So understand one thing, suppose if somebody is asking, just hear to it, it's English, although, I mean nobody is going to confuse you like this, but still I'm saying, if suppose somebody is saying, find the quadratic polynomial whose zeros are 2 and 3, is my question correct or wrong? Tell me. Find the quadratic polynomial whose zeros are 2 and 3, is it true or is it correct or false? Is my question correct or false? Gaming, you don't need to know that. Is my question true or false, guys? Find the quadratic polynomial whose zeros are 2 and 3. The question is false because the means there is only one possibility. So you cannot say find the quadratic polynomial. It can be find a quadratic polynomial whose zeros are 2 and 3. Got that logic? So the polynomial can be written like this. K can be any non-zero real number, x square minus sum of these zeros, 3 plus 2 is 5. plus product of the zeros, that is 3 2s are 6, right? So infinite such polynomials are possible whose zeros are 2 and 3. I hope it is clear. But suppose we are talking about a quadratic equation. If you are talking about a quadratic equation, then there is only one such quadratic equation whose roots are alpha and beta. You got that logic? Oh, that is infinity learned by Sri Chaitanya. So you see, quadratic equation will be one only. You got that logic? Only one quadratic equation is there whose roots are alpha and beta. Because even if you multiply by any non-zero real number, that will go on the other side of the equation and it will become 0 only. You got that? So only one quadratic equation is there whose roots are alpha and beta. But there are infinite such quadratic polynomials whose zeros are alpha and beta. Got that logic? Joinil, I hope it is clear now. Simple logic it is. So there is only one quadratic equation whose roots are alpha and beta, but there are infinite such quadratic polynomials whose zeros are alpha and beta. Simple logic it is. I hope this is clear to everybody in this session. Simple logic. Any doubt in this, guys? These are very basic things, and I hope you got the derivation as well. It is not derivation, it is just multiplication, you can say. I hope it is clear. Right? So can you do this question over here? A quadratic polynomial whose zeros are -3 and 4. So out of the given options, you have to tell. Okay, can you tell me the answer, guys? A simple question. And we are going to do transformation of equations as well. You don't have to bother about that. Obviously, every type of transformation we are not going to do, but some of them we can do. Can you tell the answer over here, guys? What will be the answer in this case? I'm sure that B is not the answer, Joinil. So what I had said is you have to work according to the options over here. So you will say that that quadratic polynomial is k, you can take any non-zero real number, x square minus sum of the zeros. Sum of 4 and minus 3 is what? 1. So it will be minus x plus product of the zeros. So product of the zeros will be minus 12. So the polynomial must be of this form or not? Tell me. X square minus x minus 12, and k can be any non-zero real number. You got it? So you see, the first one is not working over here. We want minus x minus 12. Second one is also not working because over here plus x plus 12 is there. But you see, third one will work. I can take 1 by 2 as common. So what will be left over here? X square minus x minus 12. You got that logic? X square minus x minus 12 is there. K can be any non-zero real number. So over here in place of k it is half. So therefore option C is correct. Is it clear to everybody? Any doubt in that? Option C is correct over here, guys. If you talk about this one, suppose you are taking 2 as common. So you will get x square plus x minus 12. So are you getting something of this form? Are you getting x square minus x minus 12? No. So this one is not working now. Is it clear? Exactly. Is this clear, Sajjad, Joinil? Yes. Simple question. Gaming, is it clear? Any doubt in this thing? A very, very basic question, guys. It's your school level question only. I hope it is clear. Let's move on to the next thing over here. Can you do this one? Find the quadratic polynomial. The question is wrong basically, I would say. The question is technically wrong. I had already said that. In place of the, it cannot be there. A can be there. So infinite possible answers are there. You know that. But normally, why will you play with the answer? You will just put k is equal to 1. That's it. You will just put k is equal to 1 and that is the answer. Don't put like k is equal to square root of 8, something like that. Don't confuse the examiner, right? I hope it is clear. So just put k is equal to 1 and you'll get a simple answer. Otherwise, infinite such polynomials are there whose zeros are these. I hope it is clear. Why is it so, Joinil? Why are you getting something like that? Okay, you must have done like that. Let's see if it is correct or not. Okay. So a quadratic polynomial whose zeros are this will be what? It can be k, any non-zero real number, into x square minus sum of the zeros. So if you add them up, if you add these zeros, what will happen? Plus root 2 and minus root 2 will get root 2, plus 2 root 3 and minus 2 root 3 will be cancelled, or I can show it so that it is not confusing, 5 plus 2 root 3 over here, plus 5 minus 2 root 3 is there, right? So I can cancel out 2 root 3 over here, guys. So that will give us 10 only. Clear? So x square minus 10x over here, plus product of these zeros over here will be what, guys? Yeah, let's do this. Product of these zeros will be what? If I multiply these zeros, it will be 5 plus 2 root 3 into 5 minus 2 root 3, right? So you can basically use a plus b, a minus b identity over here. So that will give you 5 square minus 2 root 3 the whole square. Is it clear? So 5 square is 25 over here and 2 square is 4 and this is 4 and square root of 3 the whole square is 3 only. So 4 3s are 12 basically, right? So this will give you 13. So I can say 13 will come up over here. Is it clear? So this is the quadratic polynomial whose zeros are this thing, right? In place of k, you can put anything. It's all up to you. You can put 1, 2, 3, 4, 5, 6, anything. Is it clear to every student in this session? Very good. Is it clear, Joinil? Any doubt in that? Nishat, is it clear? Any doubt in this question, guys? It's a simple question. You can use identity over a plus b, a minus b identity. Okay, Himadri. Okay, so let's move on to the next thing over here. So you see there are some rules. Obviously, when you get an objective question, you can use these rules. But if it's not an objective question, you cannot use these rules. I mean, if it's a school level examination question, you have to write everything possible. But suppose it's an objective question, you can quickly do the answer. For example, to form a polynomial whose zeros are k times the zeros of the polynomial, replace x by k. What does it mean? Suppose I've got a polynomial over here, simple polynomial, any simple polynomial I'm taking, right? So suppose this is 5x and this is 8, right? Now I want a polynomial, suppose the zeros of this polynomial are alpha and beta. And I want a polynomial whose zeros are suppose 7 alpha and 7 beta. You got that clear? I want a polynomial whose zeros are 7 alpha and 7 beta. So what will I do? In this polynomial, I will put x is equal to, in place of x, I will put x by 7. You got that logic? X by 7 I will put. And that will be the answer. Obviously, you have to work according to the options, but this is the polynomial whose zeros are 7 times of the zeros of this actual polynomial. Is it clear? I'll explain. Oh, this is a question, Sajjad. This is a question. See, understand the question. Suppose a polynomial is given to you whose zeros are alpha and beta. Now the question is, find a polynomial whose zeros are 7 alpha, 7 beta. Got it? Whose zeros are 7 times the zeros of the actual polynomial. So how can you find that polynomial? In the actual polynomial, put 7 divided by x divided by 7. Because it was 7 times, so in the actual polynomial, you will put x divided by 7. If it would have been alpha by 7 and beta by 7, what would you have been doing over here? In the actual polynomial, you will put 7x, right? You will put 7x. Got that logic or not, guys? Tell me. The method is clear. I will explain the logic as well. It's not a very big deal. Is it clear to everybody in the class? The shortcut is clear or not? Tell me, guys. Sort of the given options you can choose. I mean, this will work in competitive examinations. Every time it's not going to work actually. So understand it like this. See, just understand it like this. Suppose the actual form of the polynomial is, it's a quadratic polynomial. Suppose ax square plus bx plus c. Okay, you have got this polynomial. The zeros of this polynomial are alpha and beta. Now you want a polynomial whose zeros are 7 times the zeros of this polynomial. It means they are 7 alpha, 7 beta. They are 7 alpha and 7 beta over here, right? So how will you actually find it? Tell me. The actual method will be what? The polynomial will be x square minus sum of these zeros. So sum of them will be what? Just see it properly. 7 into alpha plus beta into x plus product of the zeros. Yes or no? So that is 7 alpha into 7 beta. Is it clear? Something like this? Any doubt? right? This thing is clear over here, guys. Okay, now basically see, this polynomial is what actually? Isn't this polynomial of the form, tell me, it is of the form a into x minus alpha into x minus beta form, right? It is of this form or not? Wait, I shall prove it. A you don't know, right? I can just, or maybe I'll write A as well for you. So this is basically something like this or not? Tell me. X square minus alpha plus beta into x plus alpha beta. Something like this it is happening or not over here. So what I can do over here, guys, in this polynomial, what I can do? Tell me. So this polynomial can be written, wait. Okay, so in place of alpha plus beta, basically, wait, this is minus 7. In place of alpha plus beta, you have studied this thing in the earlier sessions. Alpha plus beta is nothing but minus b by a or not? Tell me, guys. Alpha plus beta is minus b by a. So I can put minus b by a or not? Tell me, guys. And over here, this is 49, and alpha beta from the original polynomial. From the original polynomial, can I put alpha beta is equal to c by a? You have studied this thing. This I can put c by a over here. So this is c by a. You got that logic over here or not, guys? Tell me. So basically what is happening over here, guys? So I want to prove it that I am putting, wait, I want to prove it that I am putting it 7x times, right? So what I can do over here is, wait, so first I will take LCM over here, right? So let's take the LCM first. So I want to put, explain that, right? So this is 7bx plus 49c and divided by a over here, right? I hope up till here it is clear to everybody in this session. Up till here this is clear. Now I want to put, I want to explain over here that I am putting 7x the whole square, right? So over here in this polynomial, wait, can I take, give me some seconds, guys. In place of x, we are putting x by k, right? So in place of x, we are putting x by k over here. Okay, fine. So can I take 49 as common? Tell me. I can take 49 as common in the numerator or not? Tell me. So will I get, okay. I was comparing with this and therefore it was creating confusion. No problem. So this will be x by 49 over here or not? Tell me. X square by 49. I hope this is clear. And this is 7bx by 49. And this is coming out to be c and the whole divided by a. Is this thing clear? It is very important. I hope this is clear. So basically it is 7 alpha na. So I will put alpha by 7. You got that logic? X by 7 I will put na. So after simplification, what will you get in this case? Understand it very properly. This is very important to understand. The derivation I am explaining, right? See it over here. So if I remove it from here, obviously you cannot understand it from the next slide, therefore I have to do it over here, right? So you see, if I just simplify this thing, so will I get 49 upon a, and that is coming out to be a into x by 7 the whole square, and then over here you are getting b into x by 7 over here plus c. Am I getting something like this over here? Tell me. So what does it mean? You don't have to bother about the coefficient, right? You don't have to bother about this thing, right? You just have to bother that you see in the actual polynomial, am I putting x by 7? In place of x, am I putting x by 7? Tell me. The actual polynomial was ax square plus bx plus c. In place of x, am I putting x by 7? You see this. Am I doing that? Exactly. Exactly, dead official. Is it clear to everybody in this session? So it means if the zeros of a polynomial are 7 times the zeros of this polynomial, you just have to put x by 7, right? Is this clear? Is the derivation clear to everybody? Nishchal, Sajjad, dead official Himadri. Any doubt in this thing? Got it or not, guys? So this is a trick, because if you will actually use the method, it will waste your time, right? In objective questions, you can directly do, just put in the polynomial x by 7, you'll get the answer. It means, just I'll quickly tell that, if suppose there is any polynomial whose zeros are, suppose I'm taking alpha and beta only, and you want a polynomial whose zeros are, suppose 8 alpha and 8 beta. So what you will do, you'll just convert x to x by 8 in the actual polynomial. You got that? In the actual polynomial, put x is equal to x by 8. That's it. Suppose you want a polynomial whose zeros are alpha by 8 and beta by 8. What you will do, in the actual polynomial, in place of x, just put 8x. That's it. Any doubt in this thing, guys? Clear as sabko? Derivation is also clear. Obviously, nobody is going to ask this derivation. I'm just saying that because this is not there in, this is not normally in grade 10, right? These things are in competitive examinations like NTSE Olympiad and maybe in IIT JEE. I hope it is clear to everybody, right? So let's move on to the next thing over here, guys. So in the same manner, to form a polynomial whose zeros are negatives of the zeros of the polynomial, replace x by minus x. That's it. It's very simple. Now this one is same thing. Now see, suppose the zeros of a polynomial are alpha and beta. You want a polynomial whose zeros are minus alpha and minus beta. So it is the same thing which we did in the previous session, right? See, if alpha, this thing is converting to k alpha, k beta, so what you were doing, x, you are converting to x by k, correct or not? You just think that in place of k minus 1 is there. You got that logic or not? In place of k minus 1 is there. So x will convert to what? X will convert to x by minus 1, or you can say it is nothing but minus x. You got that logic or not? It is as simple as that. So it means if I've got a polynomial, any simple polynomial I'm taking, x square plus 5x plus 7, and I want, suppose the zeros of this polynomial are alpha and beta. Now I want a polynomial whose zeros are negative of the zeros of this polynomial. So what will I do? I'll put x is equal to minus x in this polynomial. Got that logic or not? X is equal to minus x I'll do. And obviously then I have to work according to the options. You got that logic or not? I have to work according to the options in that case. So minus 5x plus 7 over here. This is just one polynomial. Now you got that logic or not? Because you see, the reason is there are infinite such polynomials whose zeros are alpha and beta, and there are infinite such polynomials whose zeros are minus alpha and minus beta as well. So maybe in the option directly this polynomial will not be given now. You have to work according to the options, but the logic is, I hope it is clear to everybody. Any doubt in this thing, guys? Tell me. But suppose it comes in case of equation, then that becomes very simple. Hi Krishna, in case of equation it becomes very simple or not? Tell me. Just suppose I will say, if this is the equation, it's a simple equation I'm taking. Just suppose this is the equation and the roots of this equation are alpha and beta, right? The roots of this equation are alpha and beta. So find an equation whose roots are, suppose 3 alpha and 3 beta. Tell me. Then the answer will be a unique equation or not? Tell me. Then the answer will be a unique equation. Then you don't have to bother. Find an equation whose roots are 3 alpha and 3 beta. So what you will do, you'll directly put x is equal to x by 3 or not? Tell me. You will put x by 3 over here. That's it. In place of x, put x by 3. And then this is 2 and this is equal to 0 over here. And then you can obviously have to simplify. Don't leave it like this, because the answer in this form is not correct, right? I mean, it depends on the question. I hope you got it properly. So if you take the LCM, what will you get? You'll get x square plus 9x plus 18. Correct or not? And that is equal to 0. So you will say x square plus 9x plus 18, the roots of this equation will be 3 alpha and 3 beta if the roots of this equation they are alpha and beta. You got it? So in case of equations it becomes very easy. But in case of polynomials, you know that there are infinite such possibilities. Is it clear to everybody in this class, guys? Any doubt in this concept? Transformation basically. Is this clear? And if you want, you can verify it as well, right? According to the options, you can verify that as well. Now, to form a polynomial whose zeros are k more than the zeros of the polynomial. So, using polynomial, I hope you understand. For example, you have got this, any polynomial you can take. Suppose again I am taking a simple example, anything I am taking, right? This. Suppose the roots of this polynomial are alpha and beta, right? And suppose I want a polynomial whose zeros are k more than the zeros of the polynomial. It means I want a polynomial whose zeros are, suppose, alpha plus 9 and beta plus 9, right? We are just talking about polynomials. You got it? I want a polynomial whose zeros are alpha plus 9, beta plus 9. So what will I do? I'll change x to x minus 9. Got it? Opposite of it. X of x minus 9 in this polynomial. And see, this can also be proved like I proved this thing. Obviously, I'm not going to do the whole thing again. It will waste our time, right? So I have to just put it over here, right? So again, don't get confused in polynomials and equations, because you'll not get a unique polynomial. No unique polynomial is there whose zeros are alpha plus 9 and beta plus 9. So that polynomial can be written like this. In this polynomial, put x is equal to x minus 9, right? That is the answer. X is equal to x minus 9. Now, this is the unique, this is not the unique polynomial, because over here as well, infinite values of k, they are possible. You got that logic? But suppose it is asked in case of equations, then you'll get a unique equation. For example, I take this as an equation only. I take this thing plus 5x plus 8, that is equal to 0. And the roots of this equation, suppose they are alpha and beta, right? The roots of this equation are alpha and beta. So the question is, find an equation whose roots are, suppose, alpha plus 2 and beta plus 2. Whose roots are alpha plus 2 and beta plus 2. So what you will do? You will directly take this equation, and in place of x, because it was alpha plus 2, you will put x minus 2. That's it. And this is the unique equation. X minus 2 plus 8, that is equal to 0. That's it. You can simplify this, and this is the unique quadratic equation. You got that logic? Just simplify, you'll get the answer. So you can simplify it quickly. Maybe, okay, this is 3x square minus 4 3s are 12 minus 12x plus 12 plus 5x minus 10 plus 8, that is equal to 0. So let's simplify it, guys. Over here, it will give us 3x square, and this will give us minus 7x, and this is plus 10, right? Yeah, that is equal to 0. So you see, the roots of this quadratic equation will be alpha plus 2, beta plus 2, if the roots of this quadratic equation are alpha and beta. You got that logic, guys? Tell me. You got that logic? So quadratic equation will be unique, but polynomial will not be unique, right? And this is not just about quadratics. It is about a polynomial of any degree. It is not just about quadratic polynomial. It's about a polynomial of any degree. You got that logic? Mean by square root? Not able to understand your logic, Subrat? I hope it is clear. So Subrat, basically if you write like this, square root of 4 square, you say it is plus 4. And basically if you take, okay, so there is one more thing, square root of x square, if you are taking, this we take every time to be equal to modulus of x, right? I hope that is clear to you. Right, Subrat? It means a square root can never give you a negative value. So this thing basically square, okay, this is 2, not 4. Oh, I did a mistake. Okay, that is 4 only. Wait. Okay. Now basically this thing is different from x square is equal to 4 square. They are different from each other. You got that logic? Over here you will get x is equal to plus minus 4, because this is a quadratic equation. This thing and this thing, they are different from each other. I hope it is clear, Subrat. Your doubt is that only, I think. Okay, so in that manner, I think I'll not be able to clear your doubts, Subrat, because it will take too much of time. I hope it is clear. Hello, Sachin, welcome to this session. So I hope this logic is clear to every student in this session. So in the same manner, to form a polynomial whose zeros are reciprocals of the zeros of the polynomial, replace x by 1 by x. It means that suppose I've got a polynomial 3x square plus 5x plus 7, whose zeros are alpha and beta, and I want a polynomial whose zeros are 1 by alpha and 1 by beta, right? So what I will do, in place of x, I will put 1 by x. See, the proof I did already. For every type, I'll not do the proof. I hope you understand that. It will take like 2 hours, right? So this is the polynomial. You can simplify over here. So what will you get over here, guys? So you'll get 3 plus 5x plus 7x square. And obviously over here, this will be, k will be multiplied, right? I hope that is clear. It will be of this form, right? If you take x square as the LCM over here, so x square will go over there and x will be there. In something like that, it will be of this form. I hope it is clear. And if you talk about, so again I'm saying there are infinite such polynomials whose zeros are alpha and beta. In the same manner, there are infinite such polynomials whose zeros will be 1 by alpha and 1 by beta. That's very simple. But suppose I get an equation over here. For example, I'm getting 5x square plus 7x plus minus 9, suppose. Suppose the zeros of this, roots of this equation are alpha and beta. For example, I want a quadratic equation whose roots are 1 by alpha and 1 by beta. Then you'll get a unique answer. In place of x, just put 1 by x, right? So you'll get a unique quadratic equation only. So this you can simplify and you'll get the answer. Just do simplify it. So you will get 5 plus 7x minus 9x square. And if you want, you can take negative as common, no problem in that. So you'll get 9x square minus 7x minus 5, right? That is equal to 0. I hope it is clear to everybody in this session. Is it clear, guys? Obviously, it can be proved using the relationship between zeros and coefficients, or you can say roots and coefficients of polynomials and equations. I hope it is clear to everybody in the class. So that is transformation of equations. You can directly do in objective questions. You don't need to follow the whole process, because these things are also coming from the actual process only. Because if you will go into its proof, it will be done using the actual process only, right? It's nothing different from that actually. I hope it is clear to everybody in this session. So you can do this simple question. If alpha and beta, the zeros of this polynomial, form a quadratic polynomial, the question is correct mathematically. The nobody can write is correct. You can just find one quadratic polynomial. All the polynomials, they are not possible for anybody to find. So find a quadratic polynomial whose zeros are 1 by alpha and 1 by beta. So you can use the normal CBSE method, or you can do the way which I am doing. But obviously if it comes in the school examination, you cannot do, you cannot use this thing. In your school examination, if you will use this method, you will not get full marks. That is for 100% sure, you will not get full marks in your school examination. So in the school examination, you have to use the actual method, the long method. The long method will be what? See, the polynomial will be something like this. K into, it is in the form of t, so it will be t square minus sum of the zeros into t plus product of the zeros. Yes or no? The polynomial will be of this form. Correct? Now s will be what over here? Sum of the zeros will be 1 by alpha plus 1 by beta. Correct? You can simplify this thing. You will get alpha plus beta upon alpha beta. And you know that for a quadratic polynomial, alpha plus beta is minus b by a, right? And alpha beta is c by, I'm sorry for that. Alpha beta is c by a. This is nothing but c by a. So you see this will be cancelled out. So this is nothing but minus b by c. So for this polynomial, what is minus b? B over here is nothing but minus 1. So it is minus of minus 1, and c is the constant term, that is minus 4. So that will be equal to minus 1 by 4 over here. That is minus 1 by 4. Right? And what is the product? P over here is what? It is 1 by alpha into 1 by beta, and that is equal to 1 by alpha beta. And alpha beta is nothing but c by a. So this is 1 by c by a. And this is equal to a by c over here. What is a? A is the coefficient of t square, so that is equal to 1, and c is minus 4, so this is coming out to be minus 1 by 4. I hope that is clear, minus 1 by 4. So just put it over here. So that is t square minus sum of these zeros, we are getting minus 1 by 4 over here. So I'll get plus t by 4, and product is minus 1 by 4, so minus 1 by 4. So you can again simplify this thing, so you'll get k by 4, and it is basically 4t square plus t minus 1. Right? So you can put this thing to be equal to 1 as well, or you can put k is equal to 1, 2, 3, anything you want, because infinite such answers are possible. So if I'm putting this to be 1, I will say that the polynomial whose zeros are reciprocal of the given polynomial is this. This is the answer if I'm putting k is this thing to be equal to 1. I hope it is clear to every student in this session. Any doubt in that, guys? Just confirm in the chat. Krishna, Dead Official, Subrat, Sachin, Joinil. Any doubt in that? Okay, so I hope that is clear. Let's try to do one more question. Find a quadratic polynomial whose zeros are negative of the zeros of this polynomial. So suppose I'm using that shortcut method, but obviously you don't have to use the shortcut method in your school examinations. You have to do the long method only. So suppose I'm using shortcut method, zeros are negative. So if zeros are negative, x will be changed to minus x, right? So the new polynomial will be something like this or not, tell me. X will be changed to minus x over here, but infinite such possibilities are there. This will be multiplied by any non-zero number k. So the new polynomial will be anything over here. This is 5x square minus 9x plus 7. I hope that is clear to everybody. Right? In place of k, you can put 1, 2, 3, 4, root 3, root 5, pi, anything you want to put, you can put. So this will be the polynomial whose zeros are negative of the zeros of this polynomial. But if it comes in the school examination, you don't have to do it directly like this. I hope it is clear. But because I had already explained the transformations to you, therefore I'm using the shorter method. Suppose it comes in your school exam, in a competitive examination, you can do it directly, right? Now over here, find a quadratic polynomial whose zeros are square of the zeros of this polynomial. Now there are many shortcuts in that case as well, right? Square in this case also there is a shortcut, but I'm not doing that over here, right? I hope you understand that. So let us do this, whose zeros are squares. So suppose the zeros of this polynomial are alpha and beta. You want a polynomial whose zeros are alpha square and beta square, right? You want a polynomial whose zeros are alpha square and beta square. So first I want to find alpha square plus beta square, right guys? So again, you don't know alpha and beta separately, so you have to find it in terms of alpha plus beta and alpha beta only. So alpha square plus beta square can be written like this: alpha plus beta the whole square minus 2 alpha beta, right? You have studied this identity, guys. Now alpha plus beta is nothing but b minus b by a. You see, this is nothing but minus b by a, and minus b by a will be, just see the quadratic polynomial over here. So it is minus 9 by 5. So it is minus 9 by 5 the whole square minus 2 alpha beta is c by a. So that is 7 by 5. 7 by 5 over here. So just simplify this thing, guys. I hope you understand that. And the product of the zeros over here will be alpha square beta square, right? And that can be written as alpha beta the whole square. And alpha beta we already know that is equal to c by a, right? Alpha beta is equal to c by a, and that is equal to 7 by 5. So just put 7 by 5 over here. So 7 by 5 the whole square. So you know, you see we have got this sum of the zeros and product of the zeros. And if you know that this sum of the zeros is what and the product of zeros is what, you can easily find a quadratic polynomial in this case. Obviously you have to solve this. Any doubt in this thing to any student in this session? I hope it is clear to every student in this session, right? So one more question over here you can do. Just write the answer in the comment section after the class. This is your homework. Do it, guys. And in case you have got any doubt, or maybe you want some different topic or anything you want, that like you can write in the chat after this session, right? In the comment section after this session. So that's all we needed to do in this session on the Infinity Learn Class 9 and 10 YouTube channel. Don't forget to like, share and subscribe to the channel. And also don't forget to subscribe to the Telegram channel as well. Bye bye guys. We'll meet in the next class. Take care everybody.